Today, we need to cover sections 1.3 and 1.4. And these two sections are about something called slope, whatever that is. Well, once again, I'm guessing that many of you have had some algebra before, and you probably have an idea of what slope is. What's slope? Anybody remember what slope is? Okay, it has something to do with the line, and it has something to do with the line going up or going down. That's correct. Can you be more specific? Go ahead. All right, the slope tells you two things. Slope tells you two things about a line. One, you mentioned was steepness. And two, you said it tells you if the line is increasing or decreasing, and that's absolutely correct. And we'll see about that in a minute. All right, what else do you know about slope? Anything? Slope is a fraction. And when you're dealing with slope, what goes on top of the fraction? The y's? Okay, the rise. The y values go up and down. So one way we remember slope is what's called rise, which means how much it goes up and down, divided by, which means how far it goes left and right. So slope, one of the rules we use to remember slope is rise over run. Okay? The y's go up and down, so this is also sometimes written as change in y over change in x, because the x's go left and right. The x's give us our run. Then generally you'll see a fancy little formula for slope. It has y's on top and x's on bottom. Anybody remember that formula? It has y1 and y2, x1 and x2, and we add them, subtract them, multiply them, divide them, subtract. All right, so the formula you will generally see for slope is you'll see m equals y2 minus y1 over x2 minus x1. We always use the letter m for slope. Does anybody know why we use the letter m for slope? Me either. Just wondering if anybody could tell me the answer. Nobody really knows for sure why the letter m is used for slope. The best guess is that French mathematicians were the first ones to come up with this concept and write it down. And in the French language, the word slope begins with the letter m. So that's people's best guess. But nobody really knows for sure. All right, next thing I want you to notice. Notice I wrote y2. I called it y2. That's not the same as y squared. Notice that here I wrote y2, and y squared would be that. What's the difference between this symbol, y with the 2 down there, and y with a 2 up there? What's the difference in those two symbols? Very good. This one means multiply. This one means take y times y. This one, all this is saying is, this is the second y number. It doesn't mean square. Okay? So all we're saying is, take the second y number minus the first y number. And then take the second x number minus the first x number. Okay, so those are not exponents. And I'll see a lot of people write those with the powers up here. They'll write y2 and y1 with the numbers up there, and I'm going to mark that wrong if you do that. because in math that means something very different. All right, so let's draw ourselves a line here. Here's a line, and I'm going to give you 2 points on this line. This right here, this is the point 2, 1. And this right here, this is the point, oh, that one looks like it's about 6, 4. So there's a line, and there's 2 points on that line. And I want you to tell me the slope. Well, if I give you a line, and I give you 2 points on that line, how do you find the slope? You do rise over run. You simply plug it into that formula we just talked about. So you're going to have m equals y2 minus y1 over x2 minus x1. What's the y2 number? 4. Minus, what's the y1 number? 1. Why did you pick y2 to be 4 and y1 to be 1? How come you didn't say y2 is the number 1 and y1 is the number 4? How come you did them in the order that you did them? Because that's the way the teacher wrote them down. The teacher wrote this point first and wrote this point second. So I used this as the second one and that as the first one. That's all. Nothing special there. All right, x2 minus x1. What's the x2 number? 6 minus 2. So my answer is 3 over 4. So the slope of that line would be 3/4. So what does that mean? What does it mean to say the slope of the line is 3 over 4? Very good. If I start at this point right here, and I were to go rise 3, so if I were to go up 3, 1, 2, 3, and then run 4, what would run 4 mean to do? Go 4 to the right, 1, 2, 3, 4. Where do I end up? At the next point. And I could do the same thing again. It's going to go up off my graph, but I could go up 3, 1, 2, 3, and I could go right 4, 1, 2, 3, 4, and what would happen? It would be the next point. Well, it would be a point on the line. It's not really the next point. Why do I say it's not really the next point? Well, there's a whole bunch of points in between, aren't there? It might be the next point that has nice numbers without any fractions or decimals or anything, but it's not necessarily the next point. By the same token, I could also start right here. I could go down 3, which would be negative 3. 1, 2, 3. And then what would I have to do? Go left 4. Because if I had negative 3 divided by negative 4, if I divide 2 negatives, that turns out to be a positive, doesn't it? It's the same number. So I could start here. I could go down 3, 1, 2, 3. And I could go left 4, 1, 2, 3, 4. And once again, I would end up right on the line. All right, I'm going to draw another line now. And we're going to find the slope of that other line. How about this line? There's another line. Let's see, I need to give you a couple points on this line. I think this one this looks like it's about 0, 3. And this looks like it's about 2, negative 2 maybe. How would you find the slope of that line? M equals y2 minus y1 over x2 minus x1. You said it's 3 minus negative 2 divided by, oh, you got to be careful. If I go 3 minus negative 2, then I have to go 0 minus 2. I got to keep them in the same order. And that's probably the single most common mistake people make when finding slope. They'll go 3 minus negative 2, and then they'll switch the order. They'll go 2 minus 0. You got to keep them in the same order. The order doesn't matter. We'll see that in a minute. But you have to be consistent. All right, what's 3 minus negative 2? What's 5? 5. What's 0 minus 2? Negative 2. 5 divided by negative 2, that's a correct answer, but it's kind of weird. Usually when we write fractions, we put the minus number on top. Is that a correct answer? Would I take off if you left it as 5 over negative 2? No, not at all. But it just looks weird to me. We would normally write that as negative 5 over 2. Why are those the same number? What's that? Both of them are negative, aren't they? Because if I have one positive and one negative, and then I divide them, I get a negative. It doesn't matter which one's the positive and which one's the negative. All right, so notice a couple differences in these two lines. The first line, the one I drew in black, the slope turned out to be positive. The second line, the slope turned out to be negative. How come in the first line the slope is positive, but in the second line the slope is negative? Because the first line is increasing. When your line is increasing, your slope will always turn out to be positive. And the red line, the slope is negative because the line is decreasing. So that's what I meant back up here when I said slope tells you two things. One thing slope tells you is it tells you increasing, decreasing. Okay? So, if your slope is positive, line is increasing. Slope is negative, line is decreasing. All right, now let's look at the numbers. Here, again, for the line I drew in black, we had a slope of 3/4. And 3/4 is a number that's smaller than 1. It's a fraction smaller than 1. For the second line, let's forget about the minus sign for a minute. Just think about the number 5/2. 5/2, is 5/2 bigger than 3/4, or is 5/2 smaller than 3/4? 5/2 is bigger. In fact, 5/2 is 2.5, bigger than 3/4. And look at the two lines. The line I drew in black is kind of flat, kind of shallow, where the line I drew in red is pretty steep. Why did that happen? What does that have to do with the slopes? When your slope is a bigger number, like 5/2, the line is going to be steeper. And when the slope is a small number, like 3/4, the line is going to be not steep. Shallow is the fancy math word we use. But not steep is a good description also. All right, so that's what I meant when I said slope tells you about steepness. Forget about the fact that one of them is negative for a minute. That doesn't really matter. You just look at the absolute value of the number. So, the larger the slope in absolute value, and all I mean by that is ignore the minus sign if it happens to be negative. The larger the slope in absolute value, the steeper the line. All right, so that's the two things slope will tell you. Slope will tell you if the line is increasing or decreasing, depending on if the number is positive or negative. And then the slope will tell you if the line is kind of steep or if it's kind of shallow, whichever one it is. Questions about that? In order to find the slope, do I need to give you a graph? No? All I can give you is the 2 points? All right. So all I really need to write is determine the slope. And then I'm going to give you 2 points. Oh, I don't know. Somebody make up a point for me. 6, 5. And then somebody else give me a different point. 3 and 4. All right, I want you guys to find the slope. What was your answer? 1/3. Walking around, it seemed like almost everybody had 1/3. All right, so here's how I would do it. M is, I write down my formula, y2 minus y1 over x2 minus x1. And here was something that walking around I noticed interesting. Probably 3/4 of you went 5 minus 4. So you did, this is y2, this is y1, over 6 minus 3. That's x2 and that's x1. And you got 1/3, which is a completely correct answer. However, probably about 1/4 of you took y2 minus y1 over x2 minus x1, and you went 4 minus 5 over 3 minus 6. Order like that? You can, as long as you be consistent. If I call this number y2, then this number has to be x2. Conversely, if I call this number y2, this number has to be x2. You just got to keep them together in the same order. And notice when I do this, I get -1 over -3. Is -1 over -3 the same as 1/3? Yeah, how come? When you divide two negatives, you get a positive. So this is an important little thing. It doesn't matter which point you call y2 and which one you call y1 and which one you call x2 and x1. As long as you keep them in the same order and be consistent top and bottom, you'll get the right answer. Now, if I were doing this problem, I personally probably would have done it the first way. This is my personal preference. Why would I probably do it that way? Less work, how come? I didn't have to deal with any negatives, did I? So I tend to look ahead at my points, and I try to set it up so that when I do my subtraction, I'm going to get positive numbers. Can I always do that? No, because sometimes the slope comes out negative, so sometimes you're going to get a negative number. There's no way to avoid it. But that's kind of what I do. I kind of look ahead, try to see, can I make them come out positive? That saves me a little bit of work and a little bit less chance of me screwing it up. Questions about that? All right. Here's a special line. What kind of line is that? That's a horizontal line. Okay? What's the equation of that horizontal line? No, it can't be 0, comma, a number. It's got to have letters in it. It's got to have x's or y's or both. Y equals something, right? A horizontal line always has y equals some number. I didn't give you any scaling, so you get to pick your scaling, and you're telling me that this right here, you're deciding this is the point 0, comma 2, which kind of makes sense to me because it's 2 lines up. So this would be the line y equals 2. It's a horizontal line, y equals 2. I want you to tell me the slope of that line. Go ahead.
0.
0. That's correct. Why is the slope of that line 0?
The slope is a graph band by 0 over something over 0.
You had it right the first time.
0.
It's 0 over something. And why is it 0 over something? If I go from here to here, I'm going to pick another point right there. What's the coordinates of that point? Again, there's no scaling on this graph, so you get to kind of make it up. What's the x number right there? 6. And what's the y number? Y number has to be 2, because the y number is always 2. So if I go from 0, 2 to 6, 2, how much have I risen? I haven't risen at all, have I? So my rise would be 0, but my run would be, how far have I gone to the right? 6. So my slope would be 0 over 6, which is 0. So in this case, slope is, I mean, if you wanted to even write it all out, you could. It could be 2 minus 2 over 6 minus 0. That's 0 over 6, which is 0. So the slope is 0. And that makes sense, because when you have a horizontal line, it doesn't rise at all. So you're going to have 0 on top. Your rise is always going to be 0, and your run will be some number. depending on where your points are. All right, so there's a fact about horizontal lines. Fact. The slope of a horizontal line is always 0, because horizontal lines do not rise at all. They only run. Conversely, what if I draw a vertical line? Let's say I draw that vertical line right there. Again, I didn't give you any scaling, so we're just going to make up a couple of points here, which indicates the scaling. Give me a couple points on that horizontal, on that vertical line. That's a vertical line. How about that point right there? What's that point right there? -2, 2. Okay. That's believable. And how about this point right here? -2. I think that would have to be -1, wouldn't it, though, because it's down below the axis. -2, -1. All right. So what's the equation of that vertical line? No, the equation of the line is not undefined. The slope of the line, I think we're going to say in just a minute, is undefined. Like the equation of this horizontal line was y equals 2. What's the equation of this vertical line? X is always the number -2. So that's the equation of the line. Now I already kind of gave away the answer here. What's the slope of this line? Undefined. Why is the slope of this line undefined? All lines are straight. No, it is rising. It's rising a lot, isn't it? What it's not doing is it's not running. So when we did our horizontal line, we had rise over run. We had 0 up on top, which gave us 0 for an answer. When we have a vertical line, we're going to have 0 on the bottom, which is not good. So our slope would be, for this case, it would be 2 minus -1 divided by -2 minus -2. What's 2 minus -1? 3. What's -2 minus -2? 0. How much is 3 over 0? Undefined? It's not 0? No, why not? Because you can never have 0 on the denominator. Anytime you have 0 on the denominator, the answer you're going to write is undefined. So, fact. The slope of a vertical line is always undefined. Always undefined. So a horizontal line will always have a slope of 0. A vertical line will always have a slope which is undefined. And how would you like to abbreviate undefined? UND is perfectly acceptable. Abbreviations for undefined that you like. Another common one that I see is something that looks like that. Looks like a fancy 0. I'll accept that for undefined. That symbol really in math means doesn't exist. Doesn't exist and undefined are kind of the same thing. So I would accept that as the correct answer too. Other questions? All right, so that was pretty much section 1.3. Now we're going to move into section 1.4. And what we're going to do in section 1.4 is we're going to use the slope to graph lines. Back in section 1.2, we talked about graphing lines. Now we're going to come up with another way of graphing lines that I think is a lot quicker and a lot easier than building tables. And again, one that I'm guessing most of you have seen before somewhere, sometime in your life. All right, so I'm going to make up the equation of a line here. How about y equals, oh, somebody give me the equation of a line, but it can't be horizontal and it can't be vertical. 4, x minus 3. So there's our line. So here's what we did the other day. The other day, to graph this line, we went ahead and we built ourselves a table. And we always plugged in 0 because that was our favorite number. And when we plug in 0, we get negative 3. And then we might plug in our favorite positive number. In this case, I think my favorite positive number is the number 1. When I plug in 1, I get 1. And then I'll go ahead and I'll just plug in a negative number. I'll plug in negative 1. My y number would be negative 7. All right, so that gives me 3 points. That's enough to draw a line. Draw my line. I need to go 7 down. 1, 2, 3, 4, 5, 6, 7. And just a couple across here, I think. And I'll give my scaling. Mark enough things so I know that my scaling is all going by ones here. 0, negative 3 is right there. 1, 1 is right there. And negative 1, negative 7 is right there. Oops. I missed. What do you do when you miss one of your dots? You cheat and you make the dot bigger, you see. That's what you do. Even better, you use a ruler from the beginning, and then everything will be straight, and you won't miss your dots. All right, so that's what we did. That's what we did on Wednesday. Not too bad, but a little bit time-consuming. But here are some important things. Notice that we found our y-intercept. Our y-intercept is 0, negative 3. And notice that that y-intercept has something important to do with the equation. Negative 3 in the equation. That last number. So that number right there is always going to give us what? It's always going to give us the y-intercept. Because if I have y equals mx plus b, and I plug 0 in for x, if I plug 0 in for x, what am I always going to get for an answer for y? I'm just going to get b. Whatever b is. So this number, whatever this number is here on the end, that always tells you the y-intercept of your graph. This number 4 happens to be something very, very important. What's that number 4? It happens to be the slope. And let's just check that to make sure. I'll use these 2 points to find the slope. So m is 1 minus negative 7, y2 minus y1, over 1 minus negative 1. That gives me 8 over 2, which is 4. That number happens to be the slope. And it's always going to work out that way. So this equation, y equals mx plus b, we talked about this the other day. This is called slope-intercept form. And the reason it's called that is m equals the slope. And 0 comma b is the y-intercept. That's why that form of the line, y equals mx plus b, that's by far the most commonly used form and by far the most helpful form. It makes things very, very easy when it comes to graphing. It tells you the intercept, it tells you the slope, which are the single 2 most important things about any line. And then in just a second here, we'll see how easy it makes it to graph. All right, so let's do another problem. How about y equals 2/3 x minus 1. When we did this problem the other day, this one was a little bit harder because we had that 2/3 in front. We had to be a little bit more clever about the numbers we picked. We saw it wasn't such a great idea to use the numbers 1 and 2, but 3 was a good number, 6 was a good number because it got rid of the fractions. Here's all you're going to have to do now. You're going to draw your grid like so. That's exactly right. Again, I'm going to put some scaling on my axis just to show that everything's going by ones here. And all I do to graph the line is I start by graphing the y-intercept. What's the y-intercept? 0, -1, because this number right here is -1. So there's my y-intercept, 0, -1. And then my slope is 2/3. What does a slope of 2/3 tell you to do? Go up 2 over 3. You got to remember that slope always has the y values on top, up and down on top, left and right on bottom. So I start at my intercept right here. I go up 2, 1, 2, and then I go over 3. 1, 2, 3. And that gives me another dot on the line. Do it again. I can start at this dot, and I can go up 2, 1, 2, over 3. 1, 2, 3. There's another dot on the line. Or I could go back to my intercept. Instead of going up 2 and right 3, I could go down 2 and left 3. 1, 2, 3. So very quickly and very easily, without having to do any arithmetic at all, I generate lots of points on that graph. I don't have to plug numbers in. All I have to do is use my intercept, use my slope, connect the dots. And there's my graph. Questions on that? All right, one more of those. How about, let's do one with a negative slope. Y equals, give me a negative number, but I want it to be a fraction. It could be improper. I don't care if it's improper or proper. -5/4 x, and then give me another number, +2. All right, so for this problem, what's our y-intercept? 0, 2. What's our slope? -5/4. So that's a question you might be asked. Determine the slope, determine the intercept. It's right in front of you. Draw your grid. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4. -5 and -5 this way. All right, so again, to draw my line, I start at my intercept. What's my y-intercept? 0, 2, so that's right there. And then I use my slope. This time my slope tells me to go down 5 because I got -5 on top and right 4. So I go down 5, so I start at my intercept down 5. 1, 2, 3, 4, 5, and right 4. 1, 2, 3, 4, right there. Right, and the reason for that is -5 divided by 4, that's one positive number and one negative number, correct? So that when you divide, you get a negative answer. That's the same as 5 over -4. Same reason, I have one positive number and one negative number. So when you have a fraction, the negative could be on top, the negative could be on bottom, or the negative could be written in front like that. Why is that the same thing? Well, this has 5 divided by 4, but then I make it negative. So these three fractions are all exactly the same. For dealing with slope, I think it's quite a bit easier if you think of the negative number being on top or the negative number being on bottom. Because when you put the negative out front like this, people are tempted to say, well, I got to go down 5 and left 4. They're tempted to think that both the 5 and the 4 are negative, but they're really not. Only one of them is negative. Okay, so watch out for that. So I think it's best, when you have a slope, I think it's best to think of it as -5 divided by 4, and that tells you to go down 5 and over 4. Or you could think of it as 5 divided by -4, and what would that tell you to do? Go up 5 and left 4. That is still correct, yes. I can go up 5, 1, 2, 3, 4, 5, and left 4, 1, 2, 3, 4, and my 3 dots should line up straight. What you can't do, though, is you can't go down 5 and left 4. Then they clearly don't line up.
But as far as slope goes, this is the only time this is the correct way of reading fraction.
Well, any of these are correct. You can read it any of the 3 ways. Writing it this way leads to confusion. So if I'm dealing with slope, I generally will not write my answer that way because I've seen a lot of students think that both the 5 and the 4 are negative, but it's not. Either the 5 is negative or the 4 is negative. It doesn't matter which one. Not that this is wrong, it just leads to confusion. And that's why I generally don't write it that way. All right, so we have our 3 dots. We connect them. And my scaling was terrible. My line doesn't look straight at all, but it really should be. My line's got a little curve to it. Questions about that? All right, last problem of the day then. How about 3x minus 4y equals 8. I want you to tell me the slope. I want you to tell me the y-intercept. And I want you to graph. Throw my graph down here. What would you do? Do what? Minus 3x and then divide by negative 4. So what are you doing? You want to get y all by itself. Why do you want to get y all by itself? Because that puts the equation in y equals mx plus b, which is called slope-intercept. So there is actually a very good reason to get y all by itself. The other day I said you don't necessarily always want to get y all by itself. There actually is a pretty good reason for doing that. Getting y all by itself is going to tell you the slope and tell you the intercept. So it is really a pretty good thing. All right, so I'm going to subtract 3x on both sides. I'm going to have minus 4y is minus 3x plus 8. And then I have to divide by negative 4. And when I divide by negative 4, I have to do it everywhere. So y is, I think I would write that as 3/4, because 2 negatives make a positive. X minus 2 there, because I've got 1 positive and 1 negative on that. 8 divided by negative 4 is negative 2. Now that I have it written that way, the answers are all easy. What's the slope? 3/4. What's the intercept? All right, a lot of people will say negative 2. Personally, I don't like negative 2. Your book accepts negative 2 as an answer. I really prefer 0, comma, negative 2, because the y-intercept is a point. The y-intercept really should have an x number and a y number. I've seen a lot of books recently get lazy and they will accept negative 2 as the correct answer. I don't like it. So I would really prefer if you write your points as 0, comma, negative 2. Here's my scaling on my axes. So I draw my graph. I have my y-intercept of 0, comma, negative 2. That's right there. And then how do I move? Up 3 over 4. That's right there. I could do it again if I wanted to. That's going to take me well off my axis, but that's okay. I could make my axis longer if I wanted to. How many points do you really need to draw? 2 is the bare minimum. Not a bad idea to draw 3 or more, though. Connect the dots. And again, I got to make my dots bigger because I missed. And here you go. Questions about that? All right, then that's it for today. We will have a quiz on, we don't have class on Monday, do we? So we will have a quiz on Wednesday. The quiz on Wednesday will cover section 1.2. Quiz Wednesday, section 1.2. Enjoy your long weekend.